All right, today we are going to go over a new topic called the remainder theorem. So make sure that you get the notes title down. 1.4a, we're doing the first part of the remainder theorem today, and then we will finish up the remainder theorem next class. So 1.4a notes remainder theorem and factor theorem, and let's get started. All right, you do not need to write this down. You do not need to write the remainder theorem down, but we are going to write down what it means. So first, let me start by reading the remainder theorem, and I'm reading right here. When we divide a polynomial f of x by x minus c, the remainder is f of c. All right, and then I wish that they put parentheses around this x minus c because this is supposed to be a factor, or like it's supposed to look like a factor with parentheses. So when we divide a polynomial by some factor looking thing, the remainder is going to be f of c. Let's write down what this means now. So what does this mean? Here we go. You need to make sure that you get all of the this means part down. So this means if you want to find the remainder of f of c, or of f of x divided by x minus c, you can just plug in c, and then this is very, very important. Remember to flip the sign on c. So like from here, you'll flip the sign and plug in c into f of x. F of c equals the remainder. And I reminded you again, remember to flip the sign on c before you plug it in for x. Okay, so please write down all of that highlighted stuff down, or please get all of that highlighted stuff in your notes. And then we'll do some problems that involve this. Oh, also we do need to cover the special situation. So really quick, also write down this special situation. The whole thing, let's write all of this down. If the remainder equals 0, or because we're saying you can plug in c and find the remainder, if f of c equals 0, because remember f of c is going to be the remainder, so 0 is the remainder, that means that x minus c is a factor of f of x, and we're going to add to this. Hold on, sorry. Oh man, sorry y'all. That means that x minus c is a factor of f of x, and x equals c is a solution to f of x. So make sure you get that down as well. And we are going to do practice problems in a second that will make all of this make a lot more sense, but you need the remainder theorem in your notes. Okay, so how do we use this information? These are also very important, these 3 ways that we can use this information. So I would love for you to get this down in your notebook. If you aren't able to get it down in this time, remember this is in the content library of your OneNote. So I would write all of this down in your notebook. How do we use this information? There's 3 ways mainly that we can use it. If you're asked to find the remainder, you could divide. You could divide by whatever they give you, x minus c. Or you could plug in c into f, and it will give you the remainder. So that's what that's saying. The value that you get when you plug in c, I'm right here. The value that you get when you plug in c for x and f of x is the remainder. Cool. Second, if you're asked to see if x minus c is a factor of f of x, if you're asked to see if x minus c is a factor, first find f of c. Again, plug c in, flip the sign of c when you plug it in. And then this is very important. If f of c equals 0, then x minus c is a factor of f of x. If f of c, when you plug in c, you do not get 0, then x minus c is not a factor of f of x. All right, and last, if you're asked to see if x equals c is a solution, so it might ask you, is x equals c a solution of f of x? Again, find f of c. you can plug in C. Remember to flip the sign on C. And if f of C equals 0, then x equals C is a solution of f of x. Okay, so I'm going to give you like 15 more seconds to write all of that down. I would love for you to get all of those things in your notebook. And then we'll get some practice problems or example problems. And I'm going to go pretty quick on the example problems because the most important thing today is the theorem. Okay, here we go. So example problems. Let's start with example problem 1. Make sure you get down the whole thing in your note. Determine if x plus 1 is a factor of f of x equals x cubed minus 6x squared plus 5x plus 12. Okay, one of our notes said if we're trying to figure out if something is a factor, find f of c. Plug in c for x. So first we need to say what c equals. Well, c is going to be whatever x equals. So here is we're trying to figure out if this is a factor. What does x equal for this factor? X equals -1, right? You flip the sign. So we are going to plug in -1 for x. And if we get 0, then x plus 1 is a factor. That's what our rules said. All right, so let's go ahead and do that. We're going to plug in 0, and I will do that in pink. Okay, or sorry, we're going to plug in -1 and see if we get 0. So f of -1 equals, we get -1 cubed minus 6 times -1 squared plus 5 times -1 and then plus 12. Let's go ahead and simplify that. We have, and you should be writing all of this in your notes, -1, because -1 cubed is -1. Then we have minus 6 times -1 squared. Well, that'll turn to +1, so that's just minus 6. And then 5 times -1 is -5, so minus 5 plus 12 equals, all right, -1 minus 6, that's -7, minus 5, that's -12, plus 12 equals 0. F of -1 equals 0. We plugged in x equals -1. We got 0. So we can say, so x plus 1, the factor, x plus 1 is a factor of f of x. X plus 1 is a factor of f of x because we got 0 when we plugged in the root that went with that factor. Okay, let's go ahead and do the next example. See how this is? This is a lot faster than dividing. We're checking the remainder. If the remainder is 0, then it is a factor. Anytime we plug in, we get the remainder. Okay, write down example 2, and this is a 3-part question. I'm going to give you a minute to write it down. So p of x is a polynomial. Here are a few values of p of x. P of -3 equals -1. P of -1 equals 0. P of 5 equals 4. What is the remainder when p of x is divided by x plus 1? Okay, we don't know what p of x is, so we can't divide. It's not going to help us to divide. So what are we going to do? We're going to think about, what does x equal here? So in Edpuzzle, I want you to tell me, what does x equal for that factor, x plus 1? All right, we should flip the sign. So x equals -1. Okay, if x equals -1, we could say that if we're trying to find the remainder, we could plug in -1. Flip the sign on c. This would be like the c in our rules. So we're going to say p of -1 equals the remainder. Didn't the problem give us p of -1? p of negative 1 equals 0. So the remainder is 0. Remainder equals 0. This is a lot faster than dividing. If you're looking for the remainder, you don't always have to divide. You can just plug in what x equals for that factor, or plug in the opposite sign. Okay, cool. Let's do this one. What is the remainder when p of x is divided by x minus 5? I want you to do this one, just like we did the first one. So what is the remainder when p of x is divided by x minus 5? You do this one. Go. All right. We should have plugged in the opposite of 5, or the opposite sign. So x equals 5. Plug in that. P of 5 will be the remainder. And they gave us P of 5 up here. So P of 5 equals 4. So the remainder was 4. Remainder equals 4. All right, sweet. Let's do this third part to this problem. Is x plus 1 a factor? This one's special. Is x plus 1 a factor of p of x? All right, really quick. If something is a factor of p of x, factor, we wrote this down, factor means remainder equals what? I want you to tell me. Remainder equals what? Factor means the remainder equals what? Go, tell me. All right, the factor means the remainder equals 0. Factor means the remainder equals 0. So we need to check, is the remainder 0? Is r equal to 0? How do we do that? We plug in x equals negative 1. So we have p of negative 1. And let's go back up to where it gave us that information. P of negative 1 equals 0. So p of negative 1 equals 0. And then because it equals 0, r equals 0. This is the remainder, right? R equals 0. And so we would say, so x plus 1 is a factor of p of x. All right, we have 2 more examples, very quick examples, and then we'll do some practice. Make sure you get all that down. I'm trying to pause so that you can get that down. Okay, let's move on to example 3. Is x equals 3 a solution of g of x? Okay, this time we're looking at what x equals. We're looking at what x equals. That came from some kind of factor, potentially. So what would the factor be that would go with what x equals? If I were to write the factor, what would I put in here? I want you to tell me, what would I put in this factor? What goes in the parentheses for x equals 3? Go. All right, and we should have said, what goes in here is x minus 3. Flip the sign. So that would be like the potential factor. But do we need the factor? No, that was just for practice. How do we find if something is a solution? Plug in x equals 3. Plug in the x value. And if g of 3 equals 0, then x equals 3 is a solution. Sweet, so let's do that. Let's plug in x equals 3. So we get g of 3 equals, and we have 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6. All right, and we need to know how to do all these without a calculator, so we're going to go through them. 3 cubed is 27 plus 2 times 3 squared is 9 minus 5 times 3 is 15 minus 6. And then I'm going to go ahead and do 2 times 9. So we have equals 27 plus 18 minus 15 minus 6. and I'll combine things just like how it's easy for me. So 18 minus 15, that would give me 3. So we have 27 plus 3 minus 6 equals 27 plus 3 is 30 minus 6 equals 24. All right, g of 3 equals 24. So let's go back to our question. Is x minus 3 a solution of g of x? Well, we needed g of 3 to equal 0 for it to be a solution. G of 3 equals 24. So, no. X equals 3 is not a solution to g of x. Okay, and that's how you abbreviate solution. All right, we have one more problem, y'all. Y'all are doing great. Last problem. Hang in there. All right. I want you to try this one on your own, actually. So you try this one on your own. P of x equals this polynomial. What is the remainder when P of x, what is the remainder when P of x is divided by x plus 1? And I'm going to give you a hint. Don't use division. Because we just learned the remainder theorem for a reason. So what is the remainder when P of x is divided by x plus 1? Think about how you could figure out that remainder. Go. All right. We need to plug in the opposite of 1. So plug in x equals negative 1 to find the remainder. So P of negative 1 equals 3 negative 1 to the 4th minus 2 negative 1 cubed. Do you see how I put parentheses around everything that I plug in? That's going to really make sure that we don't get any of these wrong. Okay, negative 1 to the 4th, that would be positive 1. So we have 3 times positive 1, which is 3, minus 2 times negative 1. So, because negative 1 cubed is negative 1, so minus negative 2, because this is 2 times negative 1, plus 2 times negative 1 squared turns into positive 1, so 2 minus 1 equals 3 plus 2, because these two things combine to make a positive, negative times a negative, plus 2 minus 1 equals 3 plus 2 is 5, plus 2 is 7, minus 1 equals 6. So P of negative 1 equals 6. When you plug this in, x equals negative 1, you get the remainder. So this means the remainder equals 6. When you plug in the solution, you get the remainder. All right, cool. Now we are going to do some practice. Good work on notes. Hopefully we got all that down, and if not, remember this is in the content library of your OneNote. All right, let's practice.